Take that like your when all the schooling is fresh. So that's one test. It doesn't get you a license. It gets you two little letters after your name. EI, you'll be, Michelle Chung, EI. That stands for engineering intern. Not the greatest of terms, but it's still pretty cool to have two letters after your name when you're only 23, 24 years old if you pass that test. So then the next thing you need to do is you basically work for 4 years under another engineer before you can even attempt what's called the professional engineering exam, a PE. This is the last thing you need to do. And the beauty of it is all you need to do is work for 4 years. So you're advancing your career, working your way up the corporate ladder, doing whatever you can in those 4 years before you take that test. And it's the last test you need to take in order to just become a fully bona fide professional engineer. So the educational path journey to become a fully licensed engineer is a lot less, a lot more lenient than a lot of other careers. So that's really it. Engineering degree, pass that first test, EI, pretty much senior year right out of school if you can. Work 4 years, take the PE exam, pass that, and you're licensed. And every 2 years you got to renew your license. That's what that last bullet point is. And you take a little class and brush up on the basics, make sure you're staying up to speed with current building code and all that. But that's the educational journey to get here. So you guys being in high school wanted to definitely talk about college a little bit because that's your next big step in this whole journey, right? And I'm going to get into all the technical stuff about civil engineering, but just like I said, when you don't look at something every day, you tend to forget. So I'm assuming everything I'm about to show you about water, sewer, drainage, you probably won't remember 5 years from now when you actually need to worry about it. But what I'd like to talk about is what you should start worrying about when going through college, right? So first, you'll never have a better 4 years if you do it right. Have fun. You don't get a certificate if you graduate in 4 years versus 5. I took 5 years, not because I failed a class. Why take 6 classes one semester when I have to work? I have other responsibilities. I'll take 3 classes a semester, live my life, and do what I got to do just to, put food on the table while going to school. So don't let that get into you. Don't let that irk you if you don't get it done in 4 years. Take 5, take 6. You'll still be only 23, 24, 25 years old. You got your whole careers, your whole lives. So don't forget to have fun when you're in college. And of course, get your good grades. Make sure the grades matter. That's how you know if you're having too much fun. Okay, that's how you know if your grades are failing, but you're having the time of your life. You got to find the balance there. You guys are going to be you're not going to be living with your parents anymore. It's the first time you're going to be adult. You ran out of toilet paper. You ran out of toothpaste. You guys got to think about growing up as men and young women in that phase as well. So balance the fun with the good grades. You get good grades, everything takes care of itself, right? So please make sure that's your number one focus.
Chris,
go ahead.
One of the teachers had a question about Florida Gulf Coast University. She said she didn't notice the logo in the screen here. So what do you know if they have an engineering program there?
I actually do not know. I did not go to Florida Gulf Coast. I personally haven't crossed paths with any fellow engineers that I can think of that have gone to Florida Gulf Coast. So I'm not 100% sure.
Okay.
Good school though. I do have friends, but not engineers that have gone to that school.
All right.
But yeah, I couldn't tell you. You got to look into it. But anyway, other things to focus on when you're in college, and this is getting a little bit more serious and specific because this stuff really is going to set you aside from everybody else. Participating in some of the extracurricular engineering clubs and societies, right? In high school, they have band, they have chess club, they have soccer, football, stuff you do outside of school, right? This is important because in college, you're going to start meeting people that you're going to cross paths with for the rest of your lives within the industry. So, it's good to start, I have friends that when we were 20, no way I thought that guy could ever be successful or my boss or anything beyond that. And here we are 10 years later and he's running his own company. You never know who's going to really shine coming out of school. So, joining these clubs just puts you in touch with more people in the industry. And I'm sure a lot of you have heard it's not about what you know, it's about who you know. This is where you take care of the who you know factor of it all, you know? So definitely looks good on resumes as well. Which I'm going to skip over to 5. Build a resume. Your resume at first is going to be, I babysitted for the neighbors. I worked at McDonald's. Whatever part-time jobs. That's okay. That's how every resume looks before they get their first engineering job. But it's good to show work experience. I love seeing resumes with restaurant experience. It tells me you can handle clients. It tells me you can handle fast-paced environments. It tells me it's working at a restaurant is a difficult job if you've never done it. And a lot of you looking for part-time work in college, I'm sure you'll see what that's like. But those are things I look for in young students when I'm trying to hire. What kind of job experience did they have? How is that environment going to help them in this environment, switching from something like a restaurant to a civil engineering career? So start to build a resume, have a job. It looks great no matter what the job is in. And that'll, and an internship is a fancy way of just saying a job specific to what you're studying for, right? Try to get those jobs if you can, even if it's just a summer gig, a part-time gig. A lot of companies offer these programs as, you don't need to wait for your junior year or senior year to start applying. Take the summer off, work the entire summer. We have a bunch of interns that work with us through the summer months. They gain valuable experience, and it's another resume builder. So look for internships as soon as freshman year. I'm going to skip over to 4, and something that there's a generation gap happening right now. AutoCAD. AutoCAD is the software we use, the program we use to develop design plans. And I'm going to share my screen and show some AutoCAD stuff later on. But a lot of the older folks in the industry didn't have to deal with that coming up the ranks. They don't have those fine-tuned skills in that software program. I personally am not fantastic at it. We're starting to see the younger generation is starting to do a little bit of it in high school and in college. And that's really where you're going to be valuable day one of your job, right? You don't know how to design a stormwater system, but if you can draw it for the engineer who does, that makes you valuable, right? That's a hell of a thing to have on your resume, even before you're having your first job. So while in school, take some classes. It's a really powerful and cool program. We'll go through it, but AutoCAD, learn that as soon as possible. And then we've already talked about the last thing on the list, the FE test. Try to take that, and if you can, pass it your senior year while school's fresh. So those are I would say the 7 best things to focus on while you're in school. Moving on. So with civil engineering, there's multiple disciplines. It's one degree, right? You go to school, you get a civil engineering degree, but then you kind of have a choice depending on what job you pick, or career you pick, with that degree. I personally am a true civil engineer, and what that I guess means is I'm responsible for water, sewer, drainage design, and project management, roadway design, those types of things. We'll touch on that later. But there's other forms of it. I told you I did geotechnical engineering for a few years. That's specific with foundations. I always say, if everyone knows what the Leaning Tower of Pisa is, it's the soils were bad, the tower started tipping. That's why there's geotechnical engineering, to prevent things like that. The soils under your building and the foundations under your building matter. You can have a job specific just to that. You can have a job specific just for bridge or structural. Same with construction or surveying or transportation, all these things on the screen here. So civil is a little bit of everything, my current job, but you can specialize in any one of these things, and you'll touch on those when you're in college. You'll have an environmental class, you'll have a roadway class, you'll have a geotechnical class. While you're in school, start paying attention to, hey, I really like this subject. Maybe I go find an internship or a job in it. So with a civil engineering degree, just want to make sure you guys are aware, there's many career options and types of engineering that you can do with it. It's not just designing, water, sewer, drainage. But speaking of that, and I know for you guys, this project, 3 of the things we got to touch on are water, sewer, drainage. So I'm gonna start bouncing back a little bit back and forth between a set of plans here and AutoCAD, and show you what these things look like on both. So water, sewer, drainage, remember that. Let's start with water. All right. some of the pictures on your screen are what things look like in construction. For instance, you have looks like a 6-inch water main pipe going to a fire hydrant. Obviously, they're going to take care of the earthwork around it when they get there, but it's coming off a water main. And this is how water main construction looks. It's really just a bunch of pipes. It's exactly what you think. Water, and real quick, the big difference between all three, and try to remember this as I continue to speak, water is pressurized pipe, right? So it's the way the water flows in the pipe, it's via pressure. The city has pumps and water treatment plants. That's kind of home base where all that pressure happens. So it's under pressure. Sewer runs by gravity. So it just kind of falls through the pipe. You need gravity for sewer to travel through pipe. And if you don't know what sewer is, sanitary sewer, it's basically everything that goes down the drain in your shower or your toilet. And then drainage, that has to do with water tables. That just goes up and down. It's not gravity, it's not pressure. It has to do with the water table in the area. And again, we'll touch base on all three of those things. But those are three major differences between the three types of utilities. So what I'm gonna do real quick is what I want to do. I'm gonna jump around here a little bit. I think the best way to explain these things to you guys is just go through one set of plans. Okay. So the project I'm working on right now, and we have a picture of it. It looks like this, I think. This is called Casamar. It's a condominium I'm working on the beach here in Pompano Beach. They actually just started construction maybe a month or two ago. But what you're seeing here, it's not real. It's a rendering. This is what you're seeing on the screen is something the architect would have done, right? The architect he's the creative genius of it all. What does it look like? The engineer is the one that makes it a reality. But this is where it starts. I get this picture. Oh, cool. We're going to be working on this, and then 2 years down the road, we're finally building it. But this is the project. I'm going to go through a set of plans. Just wanted you guys to see what it looked like, the final product, because sometimes it's hard to see plans for the first time. So here it is. It's a 20-page set of plans. This is what a civil engineer would be responsible for preparing. Cover sheet, project location, table of contents. Nothing much to explain here. The next few sheets are the legend in our plans, the general details, kind of a lot of city code in here and all that. No need to go over those. And same with the specifications, material parts. All that stuff is standard language. I don't type that every time per project. Those are kind of the standard first 4 sheets. But here we go. We're going into our first actual sheet here. This one's called the erosion control and sedimentation plan. All right. And what this is, what you're seeing here, is the existing conditions of the site. And again, I know it's hard to read plans, so I thought ahead and I pulled up the aerial. What you're going to see, I'll see if I can put them side by side. What you're going to see in this box over here is this site right here. See it? So that picture I just showed you with the condominium, we're going to demolish all of this stuff and build a condo on top. But building, that's all this stuff is. This particular plan here, erosion control, it's basically you cannot pollute any of the existing drainage, stormwater system. So nothing, I don't want to spend too much time on this plan, but it's basically a pollution prevention plan. This is where the contractor will access the site. He's got a rock bed that he's got to wash his trucks down. Same over here. And then over here, you can kind of see the line work over here. That's a catch basin, a drainage inlet where the rainwater would flow to. You got to protect those. You got to put fabric over it. You don't want construction debris getting into the drainage system, because then it goes to the ocean, and we're trying not to pollute the ocean. So this whole plan is a way to prevent pollution. I don't want to focus on this because I know you guys need water sewer drainage, but might as well go through a whole set of plans. Here's the demolition plan. Again, a picture of the existing conditions of the site. Essentially what this plan says, demolish everything within this big black line, and calls out some of the specifics. The existing electrical handhold, keep that, don't demolish that. We're doing some work across the street too. The bus stop, let's make sure that stays. So these call outs are basically things that should remain that are within this demolition box. But that's what a demolition plan basically looks like. What are you going to tear down? Everything in this box, unless I say otherwise.
I'm
Um,
sorry. If everyone else could mute your microphone, that would help. Thanks.
all right, so let's talk, just because of the order, let's talk drainage, water sewer drainage. We're going to talk drainage now. And here you're finally seeing the proposed site. And again, I know it might not look quite like this, but you got to think you're looking top down. All right. So you got the ocean over here, you got the street over here. Over here on this plan, ocean's in the back. Here's the street. And you can pretend you can kind of see through the building, right? That's going to be a parking garage on the first floor. What you're seeing is kind of the first floor plan. Okay. And that's provided by the architect, what I'm somewhat tracing in red right here. The civil engineer doesn't design the building. We design the site, which is everything around it. What I kind of trace in red real quick, that's the building provided to me by the architect. I take his CAD file and I slap it into the survey and start doing my part. So in this particular job, the drainage design is shown here. If you see, it's kind of bold. And this is what it looks like below ground. You got your driveway entrance here. And if you remember from that picture, you have the ramp that goes up to that second level, right? Right here, there's that ramp. That's what you're seeing on the plan here. And for this particular drainage design, it wasn't too complicated. What we did is we designed wells, right? So basically what happens is the water falls on the street. That's a drainage flow area. It's going to travel to a catch basin, which is here. There's a inlet. And here's an inlet. All the water is going to travel into these two inlets some way, somehow. Okay. And then it's going to work its way through this pipe system to basically make its way to the well. So you have roof drains coming from inside the building, like a gutter, basically, going right into the system, traveling through what's called exfiltration trench. That's basically a pipe in a rock bed. And that's how filtration occurs prior to discharging into the well, and the well pumps the water into the groundwater table below the earth. So that well might go 60, 70, 50 feet deep, depending on what it is. And the water all makes its way to its well, and that's where the water goes. So when it rains, that's how it doesn't flood. It goes to this well, and part of the civil engineering design for it is you have to a lot of math involved to figure out how fast is that well going to drink the water. Is going to drink the water fast enough where your site doesn't flood? Are you meeting pollution requirements, aka the exfiltration trench? Are you treating the water before you're discharging to the well? This particular site had 2 wells, probably because the first well didn't have enough capacity. And the way you check its capacity, you go out there, you do exploratory drilling, and it's as simple as drilling maybe a 4-inch hole until you hit the water table, the aquifer. And the guy will go out there, fill that pipe that he just drilled up with water, and kind of time how long it takes the water to go down. And that gives you flow, right? Volume of water over time, that's flow. So all that math and what you'll learn in school and college, basically, do these 2 wells, drink enough water fast enough to make sure this entire site does not flood. And that's drainage. And what I want
a quick question on the wells. What's the makeup of the wells? Like if you were to cut a section through a well, what does it look like? Is it rocks or
Good thing about Google, we have image search.
okay.
Probably easier to show you on an image than it is to explain it. There you go. Something like this. Right, so this is how the water gets from the site, then it gets into the well. This well is drilled. It's just a big hole in the ground, and it's got rocks around the perimeter. They have a pipe coming up, and basically the water percolates through the rocks and into the ground or the earth. So how fast does the water percolate? This water needs to percolate into the earth faster than my site floods, essentially. So that's a very generic way of what a well looks like. And to get more technical, on a civil engineering plan, this brings me to my next sheet, we have details. So when you go from your paving, grading, and drainage, now you can go reference your details. So that's what these next few sheets are. Without talking about every nitty-gritty detail, I'll go over and show you what the well detail looks like and the exfiltration trench. So real quick, that exfiltration trench, this is what I was talking about. It's a perforated pipe. It's a pipe with holes. Kind of works like a well. It's working left to right instead of up to down. Water gets into the catch basin, travels through here, percolates through this rock bed. That's considered a way of treating the stormwater prior to it making its way to the well. So the well is downstream of here. And the detail for the well would be on the next page. Right here. So this is what it looks like in the box. These drainage structures, when you're driving around, you just see those circular lids on the ground. You pop those open, it's a big old concrete box underground that you can actually access. There's the 2-foot wide lid. Underground is what it looks like. You got pipes coming into these big boxes, and then here's the well. So essentially the water comes in through the pipes here and here, and it fills up, and then eventually it makes its way into the well and into the groundwater, just like we discussed on that other picture. But that's how a well works in a nutshell, without getting into a dissertation of it all. But last thing I'll mention on the paving, grading, and drainage sheet is, yeah, that's what the drainage infrastructure looks like the catch basins, the manholes, and the pipes that interconnect them all. Another big thing on this page is you see the grading, right? That's what all these little numbers are. That's my way of, or our way of designing which way does the water go. Water is always going to flow, downstream, right? So this curve is at elevation 1060. It's going this way, 1048. So I'm sending the water this way in order to make it get into this thing over here, which is a trench drain. So all these little grades, it's probably one of the more tedious exercises you have to do with an engineering job is you have to grade the site. Over here, you have a sidewalk. You got the handicap ramp. Comes up from elevation 914 to 964. This is in feet. So the difference between 64 and 14 is 50, or half a foot, 6 inches. So those handicap ramps always come up at a 6-inch elevation. So the sidewalk's high, slopes down to meet the grade of the street, cross the street, come back up and hit the sidewalk here. And then they slope up. But that's what all these little numbers are. So your grading design has a lot to do with your drainage as well. You got to get the water to travel to the inlets, right? So that's drainage in a nutshell. And just for fun, because we said we talk about CAD a little bit, this exact same sheet, this is what it looks like in AutoCAD. Okay. This is over here, you got some colors, a little easier to differentiate between what's what. And you also have ways of isolating things. So I have all my labels calling it out, but what I can do is I can freeze some things. So maybe you can just see the site and what we want, what we care about, right? So all this stuff is just physically drawn in AutoCAD, and it's just a bunch of lines and circles and a lot of geometry. But there's the drainage in green, and yeah, this is kind of what it looks like in AutoCAD. Draw the lines, label it. So that's drainage. Any questions on drainage before I move on? Okay. We'll go over to the next plan. So these next few sheets are the details specific to the paving, grading, and drainage sheet, right? The next plan is your water and sewer plan, right? So in this particular plan, you still got the building. Again, that's the parking garage. Remember, you're looking at the roof down. So, don't pay too much attention to this. Just we're worried about the site as civil engineers. So we talked about drainage. It's kind of faded in the background of this plan because this plan's not about the drainage. It's about the water and the sewer, right? So that's why these callouts are now bold. So we'll start with water. So what the water is, we have a fire hydrant. We have your irrigation line right here, your 2-inch irrigation service. You have your fire department connection over here. Over here, you have your potable water design, your fire sprinkler design. Okay, and we'll stay focused on water. That's the sanitary. We'll come back to that. And this particular building has a restaurant or a retail right here, kind of on the first floor. So it needed its own water service with meter and backflow. And that's what this symbol is. M is for water meter. That's how you get your water bill. And the backflow preventer is what this symbol is. A backflow preventer, essentially, it lets water in one way. It lets water go this way, but it won't let it go back that way. It stops right there. Because once the water crosses your meter, it's your water, you own it. But what we're doing is, what this is, WD, that stands for existing water. This is the existing water main system that's in the city street. So what we're doing is we're tapping into the water, the city water system here. So that's what this is. We excavate down, find the water main, we cut it, or we do a tapping sleeve and valve, we tie our pipe in, install our meter and backflow preventer. So this one in particular is for this retail space. And then for this condo, this big condominium building, it needs fire sprinkler. Fire sprinkler water, it's an 8-inch water right here, 8-inch ductile iron pipe. That's the material. Fire line with 8-inch double detector check valve. Double detector check valve is just a specialty backflow preventer for fire sprinkler, but it's the same thing. You tie into the city system here, provide the 8-inch pipe with the proper backflow so you don't pollute the public system, because once this is the property line. Once it crosses the property line, it's your water. So backflow preventers are required so the water doesn't get back into the system. And just so you know what those things look like, you see them all the time driving around, but you've never noticed them. They look like this. You see them all the time in the streets, probably see them outside the front of your school, but that's all it is. It's above ground. And the water comes in, this apparatus prevents the water from going back. It's 8-inch pipe. That's what supplies your fire sprinklers. Okay. And then for the other backflow preventers, it's a similar device. It's just smaller because the pipes are smaller. But going back, so that's what these things are. Tap into your city water supply, provide your meter so you can get your water bill, and provide a backflow preventer so you don't pollute the public water supply. It's for this particular site, it's a very simple site. Notice why wouldn't I just tap into the city main one time and then stub off and supply all my water off one thing? You'll learn this in college. That doesn't work for hydraulics. Without getting into a hydraulics lesson, each one of these features needs its own tap off the city main. And that's required by building code, and again, it has a lot to do with the hydraulics, the amount of pressure of water flowing through those pipes. The more length you add to this line, the less pressure you're going to get down the stream. So that's why you do individual taps for these things. So a fire hydrant is here, and then this is for your irrigation. But what I do want to talk real quick when it comes to water, let's talk fire real quick. Right here, you have what's called a fire department connection and a fire hydrant. And if you've ever heard fire trucks called pump trucks or pump engines, this is why. This is what needs to be done here is, in case of a fire truck would park here in the street. He'd take his fire hose, he'd hook it up to the fire hydrant. His truck is a pump, and he'd hook a hose up to this fire department connection. So let's say the city water supply is losing pressure in the event of a fire. The fire sprinklers have been running, it's starting to lose water pressure. Now you can pull up a fire truck, hook up to a hydrant, and pump water right into the fire sprinkler system. So that's what a fire department connection is. It's a way to repressurize the fire sprinkler system in the event that you lose pressure. Initially, the fire sprinkler system will be supplied through here. And once you get into the building, now we're talking plumbing, civil engineering and plumbing, two different scopes. So that's why civil engineer's job ends pretty much 5 feet outside the building. But that's water in a nutshell. We talked fire water hydrant, potable water or drinkable water. For the main condo, they need a 4-inch potable line, meter backflow, and for some of these retails, just a small 1.5-inch line. And the plumber helps you size those requirements. So that's water in a nutshell. But on this plan, we also have sewer. Or real quick, any questions about water? Okay. This sewer is nice and easy, so we'll go through it real quick. Sewer is what this is. So everything that gets flushed down the toilet eventually makes its way to this one pipe and into the city sewer system. And the city sewer system eventually leads to a wastewater treatment plant where they treat the wastewater, and they either use it for irrigation water, reclaimed water, or dispose of it in a different way. But that's where it heads. It goes to the wastewater treatment plant. And the plumber takes care of all the toilets, all the sink drains, kind of gets them all coming down one single pipe, and it gets here. And the one thing you have to see here is we got it's just one simple call out. We have elevations because remember, sewer flows by gravity, right? So a pipe invert is basically the elevation of the pipe in the structure, which is just like the drainage structures we were talking about. It's a lid with a big box underground, right? So just make sure we want the sewer to travel, this way towards the city system. Obviously, the pipe has to be at a slope, right? So this elevation west, the west invert, 594 is going to be higher than where we're tying in east, 530. So it's not a lot of difference in elevation, but it went from elevation 594 to elevation 530 in this particular pipe. And sanitary sewer design is pretty simple in that regard. You have a manhole every once in a while, just in case maintenance needs to be performed and you have a way to access it. But essentially, it's just gravity. Make sure, and it slopes at typically a 1% coming out of the building. So 1% slope, rise over run, and that's how you set the elevations on your sanitary sewer. And for this particular project, the sanitary sewer is really that simple. Switching back over to AutoCAD, where it might be more fun to talk about a different one with sanitary sewer. This is a site, if you guys can see it, that has, I don't have a picture of this. This is what it looks like in CAD. It's got multiple buildings. Try to focus on the white. That's a building, 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 many buildings. So on a site with many buildings, you zoom in, the orange line work is the sanitary system. So you'll see, I'll just kind of travel here. Every building comes out of the building, goes into the sanitary main. Some buildings required more, and you really just, you follow the path. You design this pathway, and the goal is to get it offsite into the city system. So you keep following this, some way, shape, or form, the building has a way to get into the main system. And eventually it leads offsite right here into the city's main sanitary system. But I just wanted to show you, I think I can isolate it, which would be cool. No. But I just wanted to show you with multiple buildings, you might have to design a main for an entire site. So the example I gave you was very, very simple, but on another site, you could be, there's over 1,000 feet of pipe here for the sanitary, for everything that goes down your toilet. And then it's the same thing with water. Every building has a meter and a backflow preventer, or a fire department connection, or a hydrant. But what we have is the main water main, right? So each one of those things that go to the building needs its own tap. So for this particular building here, right, you have your 4-inch fire water service. You have your 4-inch fire department connection to repressurize the sprinkler system. Over here, you have your 3-inch water service for drinkable water. And it kind of is the same pattern all the way through. This building has this guy over here, and it just kind of, it's the same pattern. Each one of these things have a backflow preventer. But that's what it looks like in CAD for a different project, a little bit more complex water and sewer design. But anyway, that was water, that was sewer, that was drainage. And those are the main topics we do here at engineering, civil engineering. What I'll do here is I'll kind of just finish flipping through these sheets without talking too much about them. But these sheets get more complex. Like I said, sanitary flows by gravity, right? Here is a out of scale pipe run. This is the drainage structure. This is the pipe. This is a way to show slope. It's out of scale. Might not look like a drainage structure, but these things are actually, 10 feet wide in some circumstances. So just the vertical and horizontal scale are weird, but that's what this sheet is. It's the profile, right? You can see the vertical design of water and sewer. Here are standard details. Here's your backflow preventer detail. There's many, and these are actually city provided. Every city has their own details. So what we do is we obtain them from the city and make sure we're following city standards. Here is a hydrant detail if you wanted to take a sample of the water quality. But that's what this sheet is, and they're just city standard details. And we have a couple of sheets with these specific details. So where you see your backflow preventer, your meter, your crossing information. I have a water pipe crossing a sanitary pipe. I have to make sure I need 12-inch clearance between the two, basically. So that's where you get a lot of your information is, believe it or not, design information from the city standard details. So there's a few of these sheets. We'll go through them. And then I think the last sheet I want to show you, something else we do is we do the striping and the marking. This is the last sheet of the whole plan, sheet 20 of 20. And this is almost a common sense thing. You guys drive in the streets all the time, right? You got your double yellow, your stop bar, your crosswalk striping, those reflective pavement markers in the street. They signal that a hydrant is right there. That's how the fire truck guy knows. A blue pavement reflective marker. There should be a hydrant perpendicular with it. But yeah, this plan here, we are striping the street with the turn lanes, the center turn lane and a crosswalk here, crosswalk there. If it's bold, it's proposed, it's new work, we're designing it. If it's kind of screened in the background, it's existing striping, right? So this is the existing crosswalk. So that's really the last set of this plan. And that's, you know, it took 2 years to get to this point. So I know we could talk about it in 10, 15 minutes, but a lot of coordination with architects, plumbers, electrical engineers, mechanical engineers, the city to use their water sewer drainage, getting the permits to tie into the city-owned water sewer drainage systems. A lot of effort goes through this. And but this is kind of the engineering specific, the deliverable, right? Here's our final report, our final product. This is what you paid us for, is these sets of plans. But again, something as special as this condo, that was about 1.5 to 2 years before we broke ground. And from the day we, you know, met the architect. Yeah, that's, I'd say, civil engineering in a very quick nutshell. I'd say my presentation's about over, and I'm going to open up the floor to anybody who's got any questions.
All right. Any questions? If there are any questions, you could feel free to unmute yourself, or you could put a question in the chat. And so, Chris, thank you very much for an interesting presentation.
Yeah, thank you for that.
we really appreciated it.
It's absolutely my pleasure. Just you know, you guys know where to find me. Remember, it's about who you know, what you know, and now you guys know me, right? So
Yeah.
one day you'll be looking for a job. Try to remember.
One question for you. Are you still involved with MU's college alumni? Do you like go back, you know, when they have different events?
Yeah, here and there. What we do is we go back to colleges to really try to recruit some of the students for internships or part-time jobs. So I do that every once in a while. I'll go back to the school and talk to a bunch of young students who are interested in a career in engineering and try to point them in the right direction or potentially offer them a job. But yeah, that's my main involvement right now, going back to school. The career day, right? That's what they call it.
Exactly. Okay. And then, so one other thing is that the 5 questions, there'll be about 5 questions pertaining to what was presented. And so what we'll do, we'll try to get those questions out to your students and the teachers so that you could answer them. So it'd be specifically based on what Chris presented today. And so at this time, what I'll do, I'll just stop the recorded portion of it.